So as all are aware, decarbonizing cooling system is central to achieving sustainability climate goals. And growing cooling demand makes decarbonizing HVAC, refrigeration, and data center systems a priority. So opening up with a general question, why is decarbonization necessary in the HVAC industry? It's a very primary question, basic. Anyone to take up first?
Yeah. Hi. Um, so, um, so decarbonization is essential because now driven by the urbanization and the data center and rising cooling demand. Data centers, as we are all reading, are going to increase with the increasing load on the servers and the advances in AI. The HVAC sector must really shift to low carbon technologies, and we are one of the most responsible units here because, like one of the gentlemen mentioned, HVAC is one of the largest contributing. I think 30% of the global energy use is coming from the building sector alone. So rest of the refrigeration, etc., they are going to be just increasing, and so therefore we have a big responsibility here.
Thank you very much, Mr. Hiten, for your views. Dr. Roshni, can we have your views,
Yes,
please?
I think that with climate change, we are seeing increasing temperatures all over the world. Average temperatures have increased, and in some parts, especially like in Europe, and the summers have become so intense. So people have never used cooling technologies. Now it is becoming into play. Like people are beginning to look at fans as an option, air conditioning. So in the cooling part, and this is like a vicious cycle. So definitely looking ahead, we need to understand that we are going to see more temperatures, higher temperatures outside, and therefore cooling needs to be efficient, and definitely whatever possible ways, whether by electrification or whatever, it needs to be decarbonized.
Thank you very much, Dr. Roshni, for touching those perspectives. Mr. Vivek?
Yeah, as the panelists have rightly said, the HVA is the major energy guzzler in, if we see it as a energy Pareto in a building. So 70% of the energy is consumed by HVAC itself, and there are many areas like the scope. If we look at the scope 1, scope 2, or scope 3 emissions, all three somewhere or the other they are linked to the HVAC part. And there are if we have audited many of the buildings also, and we have observed that there are many areas where we can reduce down the energy. There are many areas where there is a wastage of energy, and which is necessary. And if we see, there is a Kigali agreement which is an international treaty signed by 196 countries, and the main agenda of getting that Kigali agreement into picture is that to limit the rise of ambient temperature but to 1.5 degrees C. And one of the area is the refrigerants which we are using in our systems, whether it's a split AC, VRF, or chillers, whatever you call it. So the coolant what we are using to remove the heat is one of the major thing which is contributing towards the carbon emissions. So if we have to look at the future prospects, so to limit the ambient temperature rise, it is very necessary to decarbonize the HVAC systems nowadays.
Correctly said. Like you mentioned, the Kigali agreement. Now the COP30 is also wanting to maintain it up to 1.5 degrees centigrade.
Right.
And they are coming out with a different sort of agreement on this. Mr. Rahul, hello.
I think most of the answers raised by fellow panelists are actually answering this question. Reason is that one, HVAC is the largest consumer of electricity in our building. We need to take care of the harmful refrigerants, decarbonization, and another important factor, especially when we are in India, is that most of the developed countries have already built their buildings. But in our
Correct.
country, we have to still build almost 50% and 60% more of what we have, or maybe we have to double it, or maybe we have to triple it. So that's where for us it's more and more important to decarbonize so that we can build the future along in a sustainable manner, as Vivek had been again and again saying. So that I
Thank you
think
very
that's where it's very important in India to decarbonize our HVAC systems.
Yes, thank you very much for your insights into it. Mr. Vishnu, may we have your views, please?
Yeah, I already spoke in the beginning. Yeah, I gave my input. It was not Mr. Hiten, it was me. I think Hiten uh, spoke right now.
Acha,
I,
okay. Yes, Mr. Hiten.
Yeah, so I feel if like as I said, decarbonization is a one step by step approach. So probably from my perspective, which I am into thermal insulation expert, so monitoring and mandatory energy audits execution we need which can contribute towards reducing carbon footprint, energy saving, and thereby we can achieve decarbonization. So this is what I have from my side.
Thank you very much for putting your views. Coming to you, Dr. Roshni. So you were talking about some passive designs in your presentations and mechanical ventilation with the heat recovery. So what I want to ask is, how can regulatory framework be streamlined to accelerate adoption of renewable technologies and green building practices for thermal comfort? Like you were mentioning ECBC and India Cooling Action Plan.
So, yeah, I think in India we have the Energy Conservation Building Code starting way back in 2007, which laid the grounds for minimum standards of energy efficiency in buildings. And that definitely covers all the four major systems, including the renewable energies, lighting, building envelope, and the HVAC and all the systems, including hot water and all of that. So it's a very comprehensive code. It's a design code, and it has, it has gone through lots of changes, including now it has become ECSBC, Energy Conservation Sustainable Building Codes. And now it is also redefined for the residential sector. So it exists, only the question is about implementation, which has been lagging, as we all know that in some states like Telangana, including Punjab, Goa has made it mandatory, but nothing has happened there. But Punjab, yes, even Telangana is good. Kerala has done very well. So some states are leading the way. Maharashtra has prepared the roadmap, but we are still waiting for. So it's all about how the state governments, take the stick, because only that really is working.
Correct. That's rightly said, Dr. Roshni. Also, there was a question in the question box. Mr. Neeraj Shukla was asking, how much energy saving in terms of percentage can be achieved by passive methods as compared to active methods?
So the basic research says that you can achieve by up to 15 to 20% energy savings from a conventional building. If you do it at the design stage. Even at retrofit, it can be done, but retrofit, the costs are slightly higher. So that is there. But the thing is that when you do a good envelope, a passive design, then the cumulative system becomes like your cooling system size is lower, and so on. So that's the big benefit. So overall, energy efficiency is achieved. As an example, we have the best example is the retrofit of the Empire State Building in New York, where it was built at a time where there was not any consideration of energy efficiency. So there were about 6,500 windows with single glazing, which were changed to triple glazing. So that itself led to a huge saving in terms of energy consumption. And then they revised the chiller sizes, made it more efficient. So overall efficiency was about 38%. So that shows how you can, do step-by-step process.
Thank you so much, Dr. Roshni. I think Mr. Neeraj Shukla would have got the answer. There was another question, Dr. Roshni, from Ashish Varmu. He's asking, does current building codes mandate or recommend passive design measures to minimize cooling demand? That is much more important than building energy efficiency.
Yes, yes. So the ECSBC has a whole section on building envelope, which gives all the standards of the U value, the SRI, the SHGC, and all of these standards are given. So you can achieve this by either prescriptive method, that is using the actual standards, or you can also do whole building simulation. So you can, combine it with the other system so that your, EPI ratio is, you're getting a good EPI ratio. So that's the codes are there. Even the National Building Code has a lot about passive design. But the thing is that these codes need to be converted into your development control regulations. Like if you go to Dubai municipality, many of these things that we are still in our code, they're already there in their regulations. So people have to mandatorily follow these things, including things for fresh air, So there's no there's no way you can avoid it. You have to do it.
Correct, correct. Thank you, Dr. Roshni. I think Mr. Ashish would have got the knowledge. Coming to Mr. Rahul. Hello. Mr. Rahul?
Yes, sir.
Yeah. You're talking about the low energy cooling, evaporative emissions, and net zero carbon. So, and which one is best, direct, indirect, or hybrid one? That is my first question.
Okay. See, it depends. So let me answer it like this. So because I mentioned something about adaptive comfort, think about an industry where, because of the processes, the temperature goes up to as high as 50 degrees centigrade and 55 degrees centigrade. So in that industry, even if you supply air at 30 degrees centigrade or 32 degrees centigrade, that is good enough. So you don't need any refrigeration based system. A simple two-stage evaporative cooling or a simple direct evaporative cooling system is good enough. But if you want to deploy this technology to a comfort area, like let's say a mall or let's say a healthcare in the health hospital, then obviously you would need some amount of mechanical refrigeration. So it again depends on the application, whether you want an industry or this thing.
So any of these systems that can meet the global climate and environmental goals, how can it support that?
Obviously, they do that because one, they use much lesser energy, only 15 to 20% energy, and then obviously water is much. I saw another question which was a very interesting question. I would like to answer that. I think that question was raised by Mr. Neeraj Shukla. He was saying that there is another problem of water now. So how are we talking about evaporative cooling, which is totally dependent upon the water? So I think that's a very valid question. But Neeraj, my answer is, till such time we are using fossil fuel to generate electricity, then using water for direct cooling would makes more sense, because when you use fossil fuels to generate electricity, you also need a large amount of water. So whatever energy savings you are able to do by using an evaporative cooling system, so you are actually saving a lot of water, which is being used to generate that kind of electricity. So that was the answer for your question.